Hello, my name is Lisa Pivnik, and this is my Physics 2212 Lab 1. So in this lab, we explored the electrical forces on charged pieces of tape, and with the physical model, we balanced the gravitational and electrical forces on a piece of tape, and were able to calculate the electrical charge from this data. And with the Glowscript code, we made a computational model to represent the pieces of tape as point charges, and then allowed the program to find the electrical charge on one piece of tape for us. The physical and computational models were then compared for accuracy. And then in this experiment, both models found a magnitude of about 1.24 times 10 to the negative 8 coulombs for the electrical charge on one piece of tape. So some of the physics concepts that were applied in this experiment were electrical forces and electrical fields. So the formula to calculate an electric force is F equals K Q1 Q2 divided by R squared, where Q1, Q2 are the two charges, R is the distance between them, and then K is a constant, which is 9 times 10 to the 9. And then we were able to set gravitational force, which is calculated by multiplying mass times the gravitational constant, and electric force equal to each other and solve for Q in this experiment, assuming that both pieces of tape had the same charge. So for the physical model in this experiment, my tape was 0.195 meters long, and then the mass of one piece was around 0.000195 kilograms, and the floating distance between the two tapes when one was hovered above the other was approximately 0.0027 meters. Then the magnitude of the gravitational force on the floating piece was around 0.0019 newtons, which was calculated by multiplying its mass by the gravitational constant, which is 9.8. And then the magnitude of the electrical force was also around 0.0019 newtons, since this is how the floating effect was achieved in this experiment. From this, the calculated electric charge on one piece of tape was found to be 1.24 times 10 to the negative 8 coulombs, which makes sense logically because it's between the charges of one electron and all of the electrons on that piece of tape. And we were able to calculate it by just solving mg equals k q1 q2 over r squared and plugging in all known values. Here's a force diagram of what's going on with the two pieces of tape. You see the top piece has the electric force going up and the gravitational force going down, and they're balanced. So thus the tape was floating or hovering. And you can see that the tapes repel each other since they both have the same charge. And that's why the electric force is going opposite to each other on the two pieces of tape. For my Glowscript model, the magnitude of one piece of tape was found to be 1.24 times 10 to the negative 8 coulombs for that electric force, just like in my physical model. And then some assumptions that were made in my model included ignoring air resistance, and then modeling the tapes as point charges with all charge concentrated in the middle of the tape, and then assuming that both pieces of tape had the same charge, and thus just solving for one Q value instead of two. Also, that said charge is evenly distributed across the tapes. So here's what some of my code looked like. You can see on the right, I have some of my constants defined from my problem that I found in my physical model, like the tape length, the mass, etc. And then on the left side, we have all of my formulas. So I found the tape mass, the force of gravity, the tape charge, surface area of the tape, and then I also calculated number of atoms on the tape, the number of excess electrons by dividing the charge by the electron charge, and then also the ratio of the excess electrons to the total number of atoms on the piece of tape. Here is what my model looked like in Glowscript. You can see the forces on the top piece of tape. You have gravity going down and electrical force going up. And then on the bottom piece of tape, you see the electrical force pointing down since they are repelling each other. So some of the values found from the Glowscript model can be seen here, including the charge, the number of excess electrons, total atoms, and the ratio of electrons to total number of atoms. And then again, some of the assumptions that were made were that they were point charges, the tapes were perfectly rectangular, and the atoms are evenly spread out on the pieces of tape. So some additional questions that we can ask is, what if electrons had positive charge and protons had negative charge? What would change? And essentially nothing would change in this experiment since the tapes would still have the same charge, even though of opposite sign now, and they would still repel each other. The only difference would be that gaining electrons would result in a positive charge and losing them would result in a negative charge. But essentially nothing would change in this experiment. And then lastly, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come in contact with anything? Well, this is important because you don't want to lose the charge on the tapes, because if they come into contact with anything, they will transfer the charges over and then the tapes will go back to being neutral. So this would essentially mess up the experiment since the tapes would no longer repel each other and you wouldn't be able to float the top piece of tape and calculate the Q value. So this was my lab one, and thank you for listening.